Hello, everyone. Welcome back. We're here with another fun-filled day of science, and I'm so excited to be here with you today. Now, yesterday we spoke about how we humans make noise, and we talked about why we make noise. Now, we know you can hear me talking right now, yes? And we know that we make noise doing lots of other things. We talked about how doing simple things like getting vitamins makes noise. Putting the lid on a chapstick makes noise. How putting a cap on a pen makes noise. Things we do make noise, make sound, okay? When I say noise or sound, I'm talking about the same thing. I'm using those two words interchangeably, okay? And we also talked about how we use those sounds in order to share moments of alarm with each other. Okay, sometimes very scary moments are happening where we need to make someone aware of a moment. Does it make more sense? Because you've all been to school, right? You've all been in a school building when we've done fire drills. Would it be, think of a fire. If there's an actual fire in the building, what makes more sense? Getting out of the building quickly or getting out of the building whenever? Getting out of the building quickly, right? So then what would accomplish that goal the most efficient way? Me going around to every classroom saying, knock, 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 hey, please leave the building. We are having a fire drill. Or sounding an alarm throughout the whole building, telling everyone, hey, get out. Probably the second one, right? Telling everyone right away, real quick, through an alarm that kind of startles you, and that's okay, to get out of the building now. It's not always a bad thing. It's kind of why I use startling alarms when I'm trying to wake up in the morning, so that it actually gets me up, even though I don't like it and it's not very nice to myself, even though it didn't work for me this morning. Okay, it's important and it gets your attention. Now, we also use noise for communication, and we talked about that for animals as well. And we talked yesterday about how we make sound and we also receive sound. Our vocal cords vibrate to make noise as humans, and our ears receive the sound. Right now, we're going to read this story, learning about how our source of sound, our vocal cords, and our receivers work together. Your source and receiver. Like other animals, you have a sound source and receiver. You actually have many sources, since you can use different parts of your body to make sounds. Can you think of any? You can stomp your foot. Stomping your foot makes a sound. Tapping your head makes another sound. But the source you use most is your voice. You also have two sound receivers. These are your ears. Let's talk. Your vocal cords are in your throat. Air from your lungs makes your vocal cords vibrate. The vibrations from these cords then move up your throat and come out of your mouth. Muscles make the space between the vocal cords bigger or smaller. The bigger the space between them, the lower the sound you make. That is why an adult's voice is deeper than a child's voice. An adult's vocal cords are larger. They create a bigger space when they are moved apart. So then here are the vocal cords. So it's like a disc, like this. So if your throat is right here, so the shape of the disc would be sitting like this in your throat. Let's listen. The human ear is divided into three main parts: These are the outer ear, the middle ear, and the inner ear. Sound passes through all three parts on its way to the brain. The outer ear includes the auricle and a tube called the ear canal. The auricle is the fleshy piece of your ear on the side of your head. It collects the sounds created by people, animals, and other sound sources. Then it guides the sounds into the ear canal. The sounds pass through the canal into the eardrum. Sound makes the eardrum vibrate like the top of a drum. Even quiet sounds cause tiny movements in the eardrum. Next, the vibrations from the eardrum enter the middle ear. The middle ear has 3 tiny bones. They are called the hammer, the anvil, and the stirrup. These bones transfer the vibrations to the inner ear. The inner ear is spiral-shaped like a snail's shell. It is called the cochlea, which is the Latin word for snail. The cochlea is filled with liquid and a strip of small hairs. The strip is called the organ of Corti, which vibrations make the hairs move. When vibrations make the hairs move, they send an electric signal to your brain. The signal is sent along the auditory nerve to the brain. Okay, now think of these questions. What is your main sound source? Okay, we talked about that. And what is your main sound receiver? How is sound produced? How is sound received? Okay, so now I'm going to read the purple box. Under pressure. The pressure of the air around you changes all the time. It changes when you fly in an airplane or ride in an elevator. A sudden change in pressure can hurt your ears. The Eustachian tube prevents ear damage when the air pressure changes. It connects your middle ear to your throat. The Eustachian tube lets air flow between your ear and your throat. This corrects the pressure in your middle ear. When the air flows in or out, it can make your ears pop. Have any of you been in an airplane? Or have any of you had like muffled sounds in your ears or have had really bad ear pressure where you felt like they've needed to pop? I have. It's not fun. If you have, you'll know it. You will know. But today, I would like you to tell me what stood out to you. What did you learn today? Did you learn something new? Did you hear something again that you already knew? Or were you surprised by something? Okay, just reflect overall on this story. Okay, there was a lot of information in here. So dissect it a little bit. Pick out pieces that stood out to you and share them with me today on your Seesaw slide. Okay? I hope you all have a great day. I will see you tomorrow for Field Trip Friday. And then not next week because we don't have school. But then I will see you again online the week after. Okay? Have a great day, everyone. Goodbye.